Alright, welcome back. Today we're going to be doing Logic-2. This is a nice brief section, only 9 problems. So let's go ahead and get started. We want to make a row of bricks that is goal inches long. We have a number of small bricks, 1 inch each, and big bricks, 5 inches each. Return true if it is possible to make the goal by choosing from the given bricks. This is a little harder than it looks and can be done without any loops. Alright, so go ahead and pause and try this one on your own. Alright, so we're really going to want to take advantage of division and mods here. So what I want to do, or what I'm going to do is I'm going to start from my goal, and I'm going to, whenever I use a brick, I'm going to subtract that value from goal. So if I use a big brick, I'll subtract 5 from goal. So it's like as if my goal moved 5 inches closer. So what I'm going to do is I'm going to use as many big bricks as possible. And then I'm going to try to get, if I have any more left to go, I'm going to use small bricks. That's my plan, right? And so like if I have a goal that's like 8, right? If I use all my big bricks, even if I had a million big bricks, since big bricks only come in 5 inches each, I'd still need 3 small bricks to get me to 8. So here's what I'll do. So um, basically, what I want to do first. So step one, I'm going to write this in comments. Is step one is use as many big bricks as possible. Okay, so um, what I'm gonna do here is I'm gonna say, let's see how I should do this. What I'm gonna do is I'm gonna get the number of inches I have in big bricks, like number of, I don't even know what to call this, but like the number of, if I were to lay out all my big bricks end to end, how many inches would I have, right? So if I have one big brick, I have 5 total inches. If I have 5 big bricks, I have 25 total inches. So I'm going to say inches big, and then this will be big times 5. And basically, if my goal is greater than inches big, so if I have more, so if even basically what this is saying is if I use all my inches from big bricks, and I still can't reach the goal, then I'm going to enter this if statement. And all I want to do is subtract the number of inches from this goal. And then but otherwise, we know that I could place more bricks than I could I could place more. How should I say this? I could place more. I have more big bricks than are necessary to reach my goal. If I were to lay them end to end, I could go past my goal. I may not be able to get to it exactly, but I could go past it. And so here's what I'm going to do, right? Basically, I can treat this else part as if I have an infinite number of big bricks because I have more big bricks than I need. So I'm just gonna assume that I have like infinite number of big bricks. So all I'm gonna do is I'm gonna say that let's imagine I had like 28 was my goal, right? So if I were to use, let's say I had an infinite number of big bricks. If I were to use all those big bricks, um, I would only have 3 inches left over, right? Because 5 big bricks would give me 25 inches, and then I'd have 3 more to go to get to 28. Likewise, if I said, let's say 37, um, then if I had an infinite number of big bricks, if I could get to 35 inches using big bricks, and therefore I'd have 2 left over. If I had, let's say 45 inches was my goal, and I used a bunch of big bricks, I had an infinite number of big bricks, I'd have 0, left to go after using big bricks because this number is a clean multiple of 5. So as you can see here, this number is just the number above it, the goal mod 5. Remainder 5. So I'm just going to set goal equal to goal remainder 5. And in fact, I can actually do this as, I can rewrite this as goal remainder equals 5. This is using the same idea as like plus equals, times equals, minus equals. Now just with mod equals, or sorry, remainder equals. So there we go there, and I'm going to remove these curly braces. Okay, and now I know that everything else to get to my goal has to be covered by small bricks. So this is a very simple check. If I have enough small bricks to reach my goal, then I'm good. And I know small bricks are 1 inch each, so I don't need to do any conversions. Um, So I just need to return if I have enough small bricks to get to my goal. So small is greater than or equal to the goal. And a lot of test cases here, but we pass all of them. So there you have it. That is how we could do this one. Yeah, if you wanted to get rid of the inches big variable, you could do that if you wanted to, but it doesn't really matter. So there you go. Again, code itself not that complicated, but it's the thinking for these kind of problems that was the harder part. So yeah, that I think is a good fun problem, especially doing without loops. All right, given three int values a, b, and c, return their sum. However, if one of the values is the same as another of the values, it does not count towards the sum. So go ahead and pause and try this. So let's see, how should we do this? So I'm going to do, again, there are of course plenty of ways to do this, but here's one that popped into my head real quick, right away. So I'm just going to go through each number, a, b, and c, and ask if this number is unique. So if it's not equal to any of the other values, then add it to the sum. That's going to be my plan. If a is not b, so I'm going to first check if a is unique. So if a is not b and a is not c, sum plus equals a. If b is not a and b is not c, sorry, sum plus equals b. If c is not a and c is not b, sum plus equals c. And then return the sum. There you go. We could do this one. Now, there are other ways to do this. So let's think about possible other ways to do this. So I'm just going to now so this was like a sort of systematic way, just try each, number. And then now what I'm going to do is I'm going to just do like a branching if statement kind of way of solving this. So if a is not b, sorry, let's actually do like the positive case. So like if a is b, then we know both a and b are not going to count, right? And so all I need to do is say if, wait, I know a and b are equal. If a equals c as well, then this will mean that they're all equal. And if they're all equal, then we return 0. Otherwise, we return the sum of the remaining ones, and the only remaining number is c. So just return c. And then otherwise, so I know a and b are different at this point. So otherwise, and I actually don't need to do else because I have a return here. So I can just say if a equals c, then if a also equals b, but I could say if a equals b here, but if I did that, I actually know at the point where my cursor is here, I know that a does not equal b, because if a equals b, it would have fallen into the first place. So I know here, I know that a does not equal b. And so therefore, I know that b will count towards the sum, so I can just return b. And then otherwise, there's the possibility that, I again don't need the else, if there's the possibility that that b equals c. And if b equals c, well, I know again that a does not equal b. I know that a does not equal b. So I know a will count towards the sum, so I can just return a. And then otherwise, I return, not the word sum, I return a plus b plus c. I believe this would work. Okay, yes, it does. And yeah, so we can get rid of these curly braces here. It may look a little weird now because I have two lines indented underneath the if, but one of them's a comment, so it gets ignored. And then here I could, do some ternary stuff. Return a equals c, 0 if it does, c if it doesn't. And there you have that one. So another way to solve it there. Let's see how they solved it. Okay, so they came to the same idea as I had, the sum idea. Cool. All right. Yeah. All right. Let's go on. Given three int values, return their sum. However, if one of the values is 13, then it does not count towards the sum, and values to its right do not count. So for example, if b is 13, then both b and c do not count. Pause and try this. All right, this one sounds like a fun one. Let's do it. So I'm just going to check each value if it's 13, and I'm going to check them in order, so a, b, and c. So if a is 13, then sum is 0 because nothing counts, right? So I'm done there. If B is 13, then only A counts, so I can just return A. If C is 13, then only A and B count, and otherwise all three numbers count. So there's how we could do that one. Again, I'm sure there are other ways to do it, but this looks good enough for me, so I'm going to move on. But given three int values, return their sum. However, if any of the values is a teen in the range 13 to 19, then that value counts as 0, except 15 and 16 do not count as teens. Or to separate a helper method, fixed teen, that takes an int value and returns that value fixed for the teen rule. And this way you avoid repeating the code 3 times to find the helper method below. So they suggest that you write a helper method. You don't have to, but you can if you want to. And I would also, by the way, recommend that you write a helper method on this one. Go ahead and pause and try this one. Okay, so maybe, so hopefully you could figure out what they were saying here when they said fix is a teen for the teen rule. Basically, what I interpret that as meaning and what I think they mean is that, well, okay, first of all, let's write this helper method that they suggest because I agree that you should write one. So basically, what I interpret that to mean is that if this number in is a teen that's not 15 or 16, then we return 0. Otherwise, we just return in. That's what I interpret that to mean and how I'm going to write this to make my code easier. So if so let's see, if in is in the range 13 to 19 and in is not 15 and it's not, sorry, not 15 and in is not 16. So oops, but 13 there. So if in is in the range 13 to 19 and in is not 15 or nor 16, then I return 0, otherwise I return in. And now what I'm going to do is I'm going to say just add up all the numbers but fixed, according to my fixed method. So this main, the noTeenSum method will be pretty simple. Fixed teen, I'm actually going to call it fixed because why not? Okay, so return, oops, fix A plus fix B plus fix C, and there you go. All right, so yeah, so helper methods, as you can see, very helpful. Yeah, so let's see if there's anything else. I don't think there's anything else I really want to say here. So yeah, good problems. I'm liking, just this is sort of a side note, but like I'm actually really liking the questions in Logic-2. I feel like they're a lot more enjoyable and like well written than the ones in Logic 1, because the Logic 1 was just getting tedious. Okay, so for this problem, we'll round an int value up to the next multiple of 10 if its rightmost digit is 5 or more. Alternately, round down to the previous multiple. Okay, so it's rounding to the nearest 10, as you know how to do probably. Given three ints, return the sum of their rounded values. It asks you to write a helper method, which I would agree you should do. Go ahead and pause and try this. Okay, so I'm going to make an int called round. Round. I don't want to call it round 10, and I don't want my parameter to be num. But okay, so we are going to round to the nearest multiple of 10. So let's think about how to do that. So okay, so of course we're going to have two cases, right? The last digit is 5 or more, and the last digit is less than 5. So let's first split it into those two cases. So if in mod 10, in remainder 10, if the last digit is 5 or greater, then we're going to have this case. Otherwise, we're going to have this case. Okay. So if it is if in remainder 10 is greater than or equal to 5, and I'm actually going to I'm going to store this in a variable. So rem. So if rem is greater than or equal to 5, then what I want to return is I want to return in plus 10 minus rem. Let's see. Yeah, I think just 10 minus rem will do it. Yeah. So if you want to think about, like, if you need to pause and think about this, please do. But this'll round it up because we can think about, right? So if I take a number like 38, so like 38, well, we know that the remainder, we know that rem is going to be 8. So if I were to round this up, what I could do, and perhaps it's easier to, it's like more intuitive if I subtract rem first and then add 10. But what I'm doing is I'm chopping off the remainder. So 38 minus 8, of course, gets me, or not chopping off the remainder, but chopping, well, yeah, I guess subtracting the remainder. This gives me a nice even round number, but I want to round up, so I add 10 back to it to get me another nice round number, which is the number rounded up. So that's basically what is going on here, why this works. And then otherwise, I just want to return in minus rem. So I want to chop it off and not add 10 here. So yeah, I'm trying to think if there's like a better way, like a more, well, a better way to do this. I could, of course, get rid of this else, but yeah, otherwise I think this is going to be just fine for me. So that'll be my round method. And of course, the roundSum method will be super simple. Okay, so round A plus round B plus round C. Okay, and how did they do it? Yeah, so they basically factored out this part. So they subtracted rem from in first, and then added 10 back if only if remainder is greater than or equal to 5, which is another, very similar, valid way to do it. Yeah, so there is this sort of a side track once again, but there is a method in the math class that we've talked about before called round. Now, let me find it here. So it returns a long. Long is not a type that we've talked about, but it's a primitive type. And we could have used the round method here. So the thing about the round method is it takes a double and it rounds to the nearest integer. And it returns that integer. Notice I'm saying integer, not int. When I say integer, that means the mathematical the mathematical concept of an integer, not the int type in Java. So it returns that integer as a long. And so basically, well, first of all, that is rounding to the nearest integer, but I want to round to the nearest 10. So what I could do is and I kind of need to think this through for myself here as well. What I could do is if I want to round a number like 38, well, I could take 38, I could divide it by 10 to get 3.8. I could then round this number to 4, and then I could multiply this back by 10. Back by 10 to give me 40. And that would be another way of rounding, sort of a weird way of rounding, rounding 38 to the nearest 10. And so I'll show you how to do that. I'm not saying this is a better way to do it, but, alternative way to do it. So what I can do is I'm going to do math.round in. I'm going to do in divided by 10, and I want to do 10.0 so that I'm doing double division and not int division. So I'm going to do in over 10. I'm going to take in divided by 10, which in this case would be my 3.8 here. And then I'm going to round it using math.round, so math.round. And then I'm going to then multiply this by 10 to give me back the rounded number. And now, notice that I told you this will return a long. So what I'm going to do is I'm going to just cast the whole thing to an int. Now let me talk about what casting means, because we've never mentioned that before. All casting does is it converts something from one type to another. So this, what I just highlighted, would have the type long, so I need to cast it to an int so that I can return it as an int. There are certain rules on what types you can convert to which other types, which I won't go into now, but we can cast a long to an int. So that's what is going to happen here. Yeah, so this would be an alternative way to do it. Yeah, so perhaps you like this way better. And I know it's kind of confusing that we have two round methods going on. So my round method that I wrote right here, this is not the same as math.round. Math.round is a separate built-in function. This method here, round, is my own function that I wrote. But they are allowed to both have the same name. And when I just say round here, it'll refer to my function, not math.round. Okay, so I think I've clicked the go button enough. Let's go on to the next one. Given 3 ints, return true if one of B or C is close, differing from A by at most 1, while the other is far, differing from both other values by 2 or more. Okay, go ahead and pause and try this. So one is close while the other is far. So that means one is close and the other is far. So both conditions have to be satisfied. So if one of B or C is close, so I'm going to say if the absolute value, I'm actually going to do a helper method called dis that's going to take two numbers, A and B, and just return the distance between them. So they're, in other words, their absolute difference. Okay, so if the distance from A to B, or I guess I'll just put from B to A, is, well, the order doesn't matter, by the way, but if this distance is less than 1, or the distance from C to A is less than 1, so that's one condition. That's the first condition. Um, and okay, so that's my first condition. I'm going to oh, actually, you know what? I'm just gonna go crazy with the helper methods. Let's also put this as a helper method. So 1 is close, int A. I'll actually just call it 1 close. 1 close, int A, int B, int C. Okay, so, and this is just going to return if this is true. And now I need to find if 1 is far, and guess what? I'm going to do another helper method. 1 far, int A, int B, int C. And my closeFar method, by the way, is going to be, is going to now just have as its body, 1 is close, and 1 is far. So, okay, so differing from the other values by 2 or more. So if the distance from A to C is greater than 2, so first I'm going to test, actually I'll test B first. I'm going to first test if B is the far one, if its distance from the other two numbers is 2 or greater. So if distance from A to B is greater than 2, and distance from C to B, I'll do B first. Again, the order doesn't matter. And the distance from B to A is greater than or equal to 2. So now that basically checks if B is the farther one. Or, and I guess I don't need to put this in an if. This will just be, I'll just be returning this. Or the distance from C to A is greater than 2. Like, so in other words, if C is the far one, so distance from C to A is greater than 2, and the distance from C to B is greater than 2. Yeah, and so that'll do that one. Whenever I span multiple lines, sometimes I like to indent them all to the same level. I think it makes it easier to see. But there we go. That is how we could do this one. Of course, there are other ways to do this. I feel like a broken record. I'm saying that so much. But yeah, this is one way to do this. If you found another way, then good for you. But yeah, let's move on. Given two int values greater than 0, return whichever value is nearest to 21 without going over. Title is called Blackjack, so that's the game we'll be simulating, I suppose. Go ahead and pause the video and try. Okay, so nearest to 21 without going over, so it can be 21. So let's see. So first thing I'm going to do is I'm going to get the maximum value. So I'll just get the bigger and smaller values. So the bigger value is going to be the max of A and B, and the smaller value is going to be the min of A and B, just because that makes it easier to think small and big. Okay, so if what I'm going to say is if the big number is less than or equal to 21, then just return the big number, right? I know that that is the closest one to 21 without going over, because obviously big is bigger than small. Otherwise, if small is less than 21, less than or equal to 21, I return small, and otherwise I know that they both went over, so I return 0. and they did it yeah, a bit differently. Let's see. So, okay, so this is kind of an interesting strategy that's worth talking about. So they are taking the two values, and then if either one is greater than 21, they're setting that to 0. So if a is greater than 1, they set it to 0, and if b is greater than 21, they set it to 0, and then they just return the max of the two values after they've been modified, if applicable. So that's a clever way to do it. And they say that this part could just be replaced by math.max. So another very concise um, solution. Yeah, I actually quite like that one. I'll rewrite that one in my editor just to show you how you could write it a little more concisely using the notes that they specify. Um, basically, they're saying if because we can reassign to our parameters, which I'm going to take advantage of. So if a is greater than 21, a equals 0. If b is greater than 21, b equals 0. And they're just saying return the maximum of a and b. And I really like this solution. That's actually very clever. So yeah, another way to do it. I'll actually leave that there. Okay. Given three ints, a, b, and c, one of them is small, one is medium, and one's large. Return true if the three values are evenly spaced, so the difference between the small and medium is the same as the medium and large. Okay, so go ahead and pause and try this. Okay, so I'm gonna kind of cheat on this one, and when I say cheat, I mean just use something I haven't told you about. Although you can totally do this using stuff I've told you about. You can totally do it. Um, but really the hard part about this problem is just getting them in order, figuring out which is the smallest, mediumest, and largestest. So let's go ahead and do that. So the way I'm going to do that is I'm actually going to put these three numbers into an array and then sort that array, and then they'll be in order. And guess what? There's a very convenient method that will sort the array for you. So that's what I'm going to take advantage of here. So I'll show you how to do it without this later. Um, but this is how I would do it because it's the laziest solution. Not the most efficient, like in terms of computing speed, but we don't really need to worry about that on CodingBat. So I'll just call this sorted equals a new int array, or I don't even need to say that because that part's optional here, equals that array, and then I'm going to sort it by doing arrays.sort, a, b, don't pass the thing, pass the array. Okay, and then now all I need to do is see that they're evenly spaced. So now I know that, I'll call this nums. So now I know that nums 0 so this is the smallest, nums 1 is the middle one, and nums 2 is the biggest. So I need to return that the difference between the first two equals the difference between the second two. And I know that nums 1 is bigger than nums 0 and nums 2 is bigger than nums 1, so I have to subtract them in that order. So that is how we could do this one. And honestly, I would like to just move on, but I feel like I'd be scamming you if I didn't tell you how to do this without this shortcut. So let's talk about that. So how should we do this? So getting the smallest and biggest one is easy. If that's all we had to do, we'd be fine because we could use math.max and math.min. But um, yeah, but also keeping track of which one's the middle is what makes this a little more annoying. So obviously there's like a brute force strategy, um, and that strategy is to just create variables that are like, um, I'll call them small, middle, and big. Um, I'm not using L because L kind of looks like 1, and I just don't want to do that. So small, middle, and big. Um, so you could just say like if yeah, I'm thinking about this and like there are a lot of I can think of a lot of ways to do it, but none of them are particularly short. So yeah, I think I'll just go with what just one of them. Just pick one way to do it. So if if A is the smallest one, so what I'm going to do actually is I'm going to get the minimum of all three numbers. So math.min, A, B, C, and then we can get the maximum of all three numbers. Actually, I don't know if I'll need the max yet. But what I'm going to do is I'm going to say if A is the min, then I know that the small one is A, the medium one is the minimum of B and C, and the big one is the maximum of B and C. B and C. And then if B is the min, I guess this should be I don't need the else technically because I know that well I suppose I do if they're if two of the elements are equal, two of the arguments are equal. So if B is the minimum, then the small one is going to be A, the middle one is going to be the minimum of A and C, and the big one is going to be the maximum of A and C. And then otherwise, I know C is the min, so I can just do an else. I don't need an else if. Otherwise, I know C is the min, so the smallest one is C, the medium one is the minimum of A and B, and the big one is the maximum of A and B. And then I'm just going to return if middle minus small equals big minus middle. And did I comment this out? Yes, I did. Okay, so dang it, I need to rename this. All right, so this is going to be annoying. And oh, okay. Sorry. If you're not a coder, you might have seen this before. But if I hold Control and click in other places, you see it's adding multiple cursors to the screen. I can now type in all of those locations at once. Um, so that's fun. But I'm gonna do this in order to kind of rename my big variable. I'm gonna try and no, those b's I want to stay the same. Um, yeah, so these are the b's I want to mess with. Okay, there we go. That to do it here. Let's see, big might not have been initialized. Oh, because this one should be b still. There we go. And let's see. Okay, so it's failing for this case. This is the case where b is the smallest one. If b equals the min, then small one is a. Sorry, small one is b, that's why. Okay, there we go. So yeah, a lot longer than what I had originally. But that's one way to do it. There are probably ways to do this more concisely, but I mean, I can't think of anyone right now. I mean, yeah, I'll try one more way to do it. So one other way to do this, I guess I can comment this out. We're getting a lot of comments now. I'm gonna also do this and then this, so maybe we can see more. But yeah, I'll also comment this out. So another way to do this would be to, let's see, we could have if a less than b, we have this as its own thing, and then within this branch, if sorry, a less than or equal to b, I guess we'll do, because they can be equal, yeah. If a is less than or equal to b, well, if b is less than or equal to c, then I know that the ordering goes a, b, c. So I just need to return if b minus a equals c minus b. Otherwise, I know that c is less than or equal to b, so the order goes a, c, b. And therefore, or I guess I know that c is strictly less than b, so I know the order goes a, c, b. So I just need to return that c minus a equals a, c, b, b minus c, b, b minus c. There's a lot of thinking. And then otherwise, if let's see, b is less than or equal to a, then I can say, okay, so I know it goes b, then so I know that b is smaller than a. And let's see. Now let's see here. In this case, this is getting annoying. This is getting long. So if b is less than c, then I know the order goes A, B, C. But otherwise, there's still the possibility that C is less than or equal to A. So else if C is less than or equal to A, then I know that the order goes C, A, B. So I need to return A minus C equals B minus A. And then otherwise, I know that that's the order. Okay, and then if I go down here, I know right here that that B is less than A. So if A is less than or equal to C, then I can return. So the order, now I know that the order goes B, A, C, so I can return A minus B equals C minus A. Hopefully I'm getting these all right because I can make one small mistake somewhere. And then otherwise there's also the possibility that, let's see, that C is less than B. So if C is less than B, so that the order goes C, B, A. And so C, B, A, so then the order, so what I need to return is B minus C equals A minus B. And then otherwise I know that the order is, I don't need these else, I suppose, this else, I suppose. And then otherwise, if B is less than A and A is less than C, then I know that's the order. If C is less than B, then I know C comes first. But otherwise, I know that the order goes B, C, A. So then I can return C minus A equals A minus C. No. The order is B, C, A, so B, C, A. C minus B equals A minus C. Yeah, so in all cases, the first one and the last one should be the same variable. Okay, and this doesn't need to be an if, because I know, obviously, that B is less than A if A is not less than or equal to B. Okay, so that's another way to do that. I feel like that code is very error prone. Like, there's a high probability. I'm surprised that I didn't make a mistake somewhere in there. Um, Sorry, I'm adjusting my microphone a bit here. Yeah, I'm surprised I didn't make a mistake somewhere there. But yeah, that is again another way to do it. You can see that both ways are much more complicated than what I had at first. But okay, we've spent enough time on this problem. Let's go to the next one. Okay, I think this is the last one too. We want to make a package of goal kilos of chocolate. We have small bars and big bars, 5 kilos each. This sounds familiar. Return the number of small bars to use, assuming we always use big bars before small bars. I'm trying to think, and I think this is actually just identical to what we had. Like the problem is not identical, but I think our solution is going to be identical to what we had from makeBricks. Um, I know I'm kind of cheating here. Um, copy pasting, I know. No. makeChocolate. And what have I done? I have, oh, I see. Return the number of small bars to use. So that would be, so once you've used all the big bars, then we're going to say so we've used all the big bars after the code above my cursor executes. So now what I'm going to do is I'm going to say if small is less than goal, then I can't make it. I return -1, and otherwise I just return goal because that's how exactly many small bars I need, and I know I have enough small bars, so I just return goal. So that will solve that one. I know I'm cheating. I'm sorry. Okay, so kilo. Let me rename the variables just so that it's more, good here. So yeah, that is a good way to do that. Let me go out. And yeah, I'm taking advantage of the fact that I guess I'll leave it zoom out like there. But yeah, I'm taking advantage that when I was writing the makeBricks problem, I already did what this problem asked. I already used all the big boxes, the big bricks first. So I can just basically copy this code, which is the code that uses all the big bricks first, and leaves goal equal to the number of small bricks needed. And then I just say if I have enough if I don't have enough small bricks, I return -1. Otherwise, just return how many I need because I have that many. So that's how we could solve this one. All right, so that's Logic-2, a nice short one. 40-minute video is short for this series. Um, so yeah, I will see you next time for string 2, and we'll get to use some loops finally. So yeah, see you then. Goodbye.